Okay. All right, we're going to do a problem 18 from the final exam. So we have a boat travels in one dimension. It's going that way. It starts with a positive velocity v0 at t equals 0, and it feels a single unusual drag force, which depends on both time and velocity. So the magnitude of the drag force is KTV. K is positive constant, blah, blah, blah. Okay. So part A, start with Newton's second law and find V as a function of t. Okay, so if we look at the free body diagram, there is a drag force opposing the motion. Fg and let's say a normal force or a buoyant force are going to be in the y direction. And we actually don't really need to worry about the y direction here, right? Because the motion is all in the x direction. Okay, so if we sum the forces in the x direction, that gives us max. In this case, the drag is in the negative x direction, so that's something a lot of people missed, didn't put that negative sign in there. Is m dv dt. Okay, so now we want to separate variables. It's a little out of focus. Here's me trying to adjust that. Okay. All right, so we're going to separate variables. We're going to bring t over to this side and bring this v over to this side. So I get negative kt dt is m dv over v. And now I'm just going to bring my mass over here as well. So I get negative k over m t dt equals dv over v. And so I'm going to integrate. Time is going to get integrated from 0 to t. Velocity is going to get integrated from v0 to v. Okay, and so here on this side, we just have t dt. We're going to integrate that. We get, and this is a constant, so that can just come out. K over m, integral of t dt from 0 to t. And so we get 1/2 t squared evaluated from 0 to t. And then we have the integral here of dv over v. So that's log v evaluated from v0 to v. Okay, so the 0 term just drops out, so we get minus k over 2m t squared on this side, and on this side we have the log of, well, let me just do it in steps. So we'd have log of v minus log of v0. So that is the same as log of v over v0, right? If you subtract logs, it's the same as the ratio. Oops, sorry. Okay, and then we can take both sides, basically raise it to e to the power, right? So that will continue over here. E to the minus k over 2m t squared equals v over v0. And then we can multiply both sides by v0. So we get v is v0 e to the minus k over 2m t squared. Part B, we just want to sketch what that looks like. So we're going to start at v0, and it's going to decrease exponentially with time, a little faster than exponentially because we have t squared. Okay, in the last part, we want to check our solution in two different ways. So what happens at t equals 0? So we have v0 e to the 0, right? Because our time is just 0 there. So that's going to go to 1, and so that equals v0. So that checks out, right? That's our initial velocity. And then as time goes to infinity, what will happen to v? We have v0, e to the minus, and again, our time squared here, so e to the minus infinity. So that's v0 over e to the infinity, and that's going to go to 0. Okay, and that's what we'd expect for a drag force. So